Hi everyone. We're Team SMCK, and we decided to pursue the Health and Sciences track. What we chose to focus on was most likely one of the biggest headlines of the year, the California wildfires. But instead of focusing solely on how they affect people in California, we wanted to look more at how they affect the health of COVID patients and the air quality of those in the neighboring states.
So we started our analysis by looking at different levels of pollutants versus how much time people were spending in parks. And here we have a graphic where size of the dots represents population of different US cities we decided to focus on, and the darkness of the dots represents the level of COVID-19 deaths per case ratio. So a darker dot represents more deadly instances of the virus in this city. And we can see that over time, there doesn't seem to be a clear relationship between the pollutants and time spent in parks, but more time spent in parks does seem to correspond to higher case fatality rates. And around here, we see certain cities that seem to spike in PM25 and CO levels. And so we decided to explore this further with another graphic. So we made some charts that look at the levels of different pollutants over time. And here we see big spikes in August and September for CO levels, for PM25 and PM10, which seem to track each other pretty well. And we also plot the change in mobility over time, which we can see that the cities that we've decided to highlight in red, which we chose because of proximity to the wildfires, including Bakersfield, Boise, Fresno, Los Angeles, Las Vegas, Sacramento, San Diego, San Francisco, San Jose, and Seattle, tend to be on the lower end of mobility, although that doesn't seem to change very much when the wildfires occur, which is a little surprising. And we made a final graph where we have the same cities that I mentioned that were highlighted in red, now highlighted in blue, and we plot on the CO and PM25 pollutants of interest against time spent at home. We hypothesized that we would see an increase in time spent at home when the pollutant levels are rising, which we do not observe here, but this may be because of differences in measuring in our data. We see around this point, our cities that are highlighted in blue seem to stand out drastically in terms of pollutant levels. And this does correspond to what we saw in the previous graphs, where these cities experience much higher levels of the pollutants during the wildfire season, generally September and August.
Awesome. So let's also take a little bit more of an in-depth look at how these fires might be affecting the atmospheric composition of neighboring areas and areas across the country. So we also made a visualization of, over the course of the summer, what atmospheric composition is looking like. So especially we're tracking the concentration of PM 2.5, also called PM 25, which is particulate matter that is over or under over the size of 2.5 micrometers. And so these are generally good proxies for air quality in an area, and so is PM10. Those particles are a little bit larger. So we can see across early July, this is a relatively constant rate. Nothing too extreme. But as we get into late July, we can start seeing, as the wildfires are kicking in, that our values across the West Coast are becoming higher. We're having a higher concentration of PM 2.5. So this viz will track composition daily across the country, across all the different OpenAQ location sites, and then also note the atmospheric conditions. So we can see, as we're in very late August here, wildfires are really kicking in gear. We can see all the way across this whole band here from Washington to California, which is sort of expected. But you can also see on the other side of the country, especially in the Northeast, you're seeing levels that are much higher than early July as well. So it just goes to show sort of this transportation effect, either by wind patterns or the like, of this smog and smoke particulates across the country. So this is not a merely localized phenomenon. It's affecting citizens countrywide. So from that, if we wanted to go further, is to explore. We already looked at how smoke and pollutants might affect quality of life and human behavior. But also be interested to see how further across the country, people are behaving in response to these added pollutants.
So from our visualizations, we were able to see that higher pollutant levels from the wildfires in California potentially have effects on individual health in terms of COVID death rates locally, but also have larger effects on the environment across the country. Yeah, so thanks for listening to our presentation.